Hi everyone, my name's Andy Leonard, and I'd like to welcome you to this presentation at SQLBits 2020 Virtual, Greatest Data Show. I am honored to be here, even virtually, speaking with you today, and SQLBits is hands down my favorite conference. I love the organizers, I love the sponsors, I love the attendees and my fellow presenters. I think it's a fantastic conference. A lot of conferences this year have been impacted by the pandemic, and switching from in-person to virtual has made an awful lot of work for conference organizers the world around. And not taking anything away from any of them, it's a hard job. I would just like to applaud, many applause, to the organizers of SQLBits. I know this was a lot of work. Thank you. So SQLBits 2020 is the greatest data show. Excited to be a part of this. And just want to remind you that Thursday night is the pub quiz and Friday night is the SQLBits party. It'll be interesting to see how both of those go. And there'll be a way for you to submit feedback forms virtually. So please do so. Follow those instructions when they're shared with you. I want to talk to you today about making SSIS go fast. I want you to run SSIS faster in your enterprise data engineering, and SSIS is built to perform data integration and data engineering. And there's just a few tips and tricks I'd like to share with you to maybe help it run a lot for you, stuff that's helped me over the years. Why am I here talking to you today about data engineering with SSIS, and why am I so concerned about making it go fast? Well, this is from a book called Unicorns Among Us. It's about 3 or 4 years old. It's a short book. I want to say it's just 100 pages or so. And I listened to the audiobook. I want to say it was about 2 hours or less. And in chapter 3, called Data Wrangling, in this book, the author describes data wrangling, which is data engineering or data integration or ETL, whatever term you want to apply to it. The author says that this is 50 to 80% of a data science time. And that's matched my experience doing large data warehouse projects, building the ETL for some enterprise class data warehouses. And I'd say it could probably go to 90%. It's just a big chunk of what's required to get data collected and get it in the shape and get the quality figured out. Data quality is huge. And SSIS does that sort of work. There's a story from politics. This is about 8 years ago in the United States presidential election when President Obama was reelected. And of course, after he got reelected, you can only be president in the U.S. for 2 terms. And after that, his data scientists started sharing how they did it. And this was a quote from a CNN article about the data science that they used to help President Obama win re-election in 2012. And he says this: "We ran the election 66,000 times every night." Now, can you run your data engineering process 66,000 times a night? It has to be designed for that, or it has to be really, really small. And this was not small. I've worked with demographics data before for a number of enterprises, and doing anything 66,000 times a night is a lot. And he talks through all of the in the article, and you can find the article on CNN if you search for it. He talks through all of the different ways that they did this. And if you look at the results of that election, from an electoral college standpoint, which I know is hard to understand if you don't live here, I've got I must share with you that it's also hard if you live here. Okay. And it was a large win electorally in the electoral college. But if you looked at the popular vote, it wasn't huge. I mean, it was within, a few percentage. And if you break that down over what it would have taken to swing the election the other way, it turns out that it's just a few votes here and a few votes there that would actually cause that to happen. And it's possible, because of the Electoral College in the United States, to actually lose the popular vote and win the election. You saw that in 2016. So just so you know, this was huge, and they credited the data science that was applied here to helping President Obama get reelected. So when I talk about, why are we talking about this, and why is this so important, you can literally change the world by using data science. And a big chunk of data science, the biggest chunk, in fact, according to this author, Lars Nielsen, would be the data wrangling side of that. So as we talk about how we might accomplish this, there's really these 3 bullets here that actually this is kind of like my mission: build data integration faster, make data integration execution more manageable. And also this bullet that we're focusing on for this delivery: build faster data integration. And that's really what we're talking about. It's 1 and 3 are close, right? But 1 is about automation and being able to build whatever it is you're going to deliver very quickly. Number 2 is about things like DevOps and designing so that it's easier to maintain. You reduce the cost of ownership over the life of the project. And what I've learned from experience, I've been doing this about 20 years now, is that there's a large sum of money, relatively large sum of money, plopped down and invested for the development effort. And most of the time, these projects run from 5 to 10 years. Usually they're north of 5 and up to 10 years. And over that amount of time, the cost of maintaining it is usually way more than the cost of building it in the first place. I've seen that number, that ratio somewhere around 1 to 10. So if you can spend a little bit more time during the development cycle focusing on how to make the data integration run faster and adding instrumentation so that it surfaces messages for you and makes it easier for you to troubleshoot, then that cost of maintenance, that's maybe 10 times as much as the cost of development, may be cut in half. I've seen those numbers, and I've delivered projects that actually. So that being said, let's dive into the focus on bullet number 3 here, which is building faster data integration. So I want to talk about ludicrous speed. Now, there's going to be movie quotes, maybe just this one, but this one's taken from Spaceballs, which is a film that's been out for a few years now. It makes fun of Star Trek and Star Wars, a bunch of other stuff. And there's a thing in there about ludicrous speed, and we're really just going to jump right into these 3 demos. I hope that's okay. I'm not big on PowerPoint. I like sharing, solutions here. So I've got Zoom It running so that we can all zoom in and see a large screen here. And the very first thing I'm going to talk about is binary large objects, or blobs. So what I like to ask when we're in person is, if you're dealing with SQL Server, what are the data types that make up binary large objects? And usually everyone will get things like text and in-text and image, because those have been blobs forever. But there are blobs that are less, things that are less well known as blobs. I call them sometimes sneaky blobs, like XML. We're going to run into that in this table that we're loading from AdventureWorks. There's 2 columns in here that are XML. Also, anything that has max, var binary max blob, varchar and invarchar max blobs. So those are kind of sneaky about being blobs. And blobs are stored on the disk somewhere. They're in a file location. And when you look at the data, that the row of data that's sitting inside of SQL Server, there's a pointer that says, hey, that blob is over there, because it can be 2 gigs. That's a lot of data. And so when it's time to read a row that has a blob in it, SSIS will do this little blob reading dance, if you will. Now, I actually do interpretive dance when I'm doing this. I'm seated. I don't have to do this while I'm seated now. But this is the dance that SSIS does when it reads and then writes a blob. So first, it starts at the blob location. It reads, it finds that pointer, and it goes and reads that file contents. And then it creates a temporary file in some directory. We're just going to imagine that some directory. We'll talk about that in a minute. Fill in that blank. Reads it, writes it to here in a temp file. Then the data flow does whatever it's going to do. And then it's time to hand off that blob. So it goes and reads from that same temp directory, and it hands it to the target or destination engine. So half of those 4 things that I listed there are happening right in the middle. Steps 2 and 3 are in this directory. And where is that directory? Well, it's your temp directory. And unless people made changes when they were installing the operating system, that temp directory is on your C drive. And the C drive happens to be busy running the server, and you don't want to add to its workload, right? I/O is the dearth of all things data. It's the thing that slows us down. But if we want to make things go faster, one way to do that is to instead of writing directly to the C drive, let's put it on any other drive. And so if I execute this, I'm just going to click the start button here. We're going to watch this run. And while this is running, I'm actually going to zoom out because I've got a little bit of time here. And I'm going to start calculator. There it is. So we can see how fast this runs. We're going to do a little math here, a little exotic math. And if we look at the progress tab here and scroll down, what we'll see is a couple of things. One is this is the data flows runtime, 8.719 seconds. And this is the number of rows that it wrote. Now it's a truncate and load, so it's relatively consistent in its pattern. So if I take the number of rows, 19,972, and I divide that by the execution time, 8.719, I get the rows per second. And I loaded about 2,290 rows per second. We'll call it 2,300 rows a second to round it up. So, that's not bad. But one of the first things you want to ask yourself, about these blobs before we get to messing around with the blob temp storage path, which is where that directory, that target directory, those middle 2 steps go to. Before we touch that, really the first question you want to ask yourself is, do we want to have blobs? I've made notes for me. This is the no blobs note. Do I want to load the blobs? And the blobs are additional contact info and demographics, 2 XML fields in the person.person table. Why is that important? Well, because, it's worth running down and asking people who use the reports, is there any information in these 2 fields that we surface on a report? And the answer to that question may be no. And why is it worth running that down? Well, I'm glad you asked. Ignore that. Let's ignore graphics. Click OK, and our error should be good. The reason that it's worth running this down, and it may take days, worth the days, is because of this. If we're not loading blobs, then it runs faster. How much faster? Let's look at our numbers. 19,972 divided by, there's our data flow, 0.297. So now we're up in the upper 60,000s. And based on just rough numbers, 2,300 to say 67,000, we're knocking on 20 times faster here, maybe 30 times. Actually, 30 times. We're coming up on 30 times faster. So if this is running in your enterprise and there's some blobs in here, some nvarchar maxes and stuff like that have maybe large data in them, stored off in the file system, this might be worth looking into. Is it in there? And not just this, but you may want to consider, okay, what if, it is, maybe we do need some data out of these XML fields. Well, would it be worth calling a stored procedure prior to this and loading the business entity ID. In this case, it's the business key plus the handful of fields maybe that are in demographics and additional contact info. Put those in a table. You just run a XML queries there, and pick that data out and stick it into a table, so you can just do a join between person.person on business entity ID and these additional tables. That's going to run faster as well because there's not going to be any blobs in there. So find a way, if you can, to get away from these blobs. I want to talk some about, now using this blob temp storage path here. And let's just pin this so it doesn't go anywhere. And click on the data flow property. This is blob temp storage path. So again, by default, it's going to be, because it's empty, it's going to be writing to your C drive and working this way. But if we change this, and I've got a folder on here called F blob temp, there it is. And in fact, we can open up Windows Explorer here, and we can actually go to that directory, F blob temp, and we can watch what's happening as it happens here when we do that. So if we put the blobs back, we'll do that here. Put them back. And map them so that we're reading and writing them on mapping here. And now if I click this input column right here, this may have been worth the cost of the class. You can actually just sort by the ignores, right? And that way you can find what's not mapped. Kind of cool. So I'm going to start this execution, and I'll flip over to the blob temp file. And you can see these files are being created and then deleted as the execution continues. So kind of cool. And just by moving them, remember we were at 2,300 rows a second a little while ago. And if we look at calculator now, we ran in 6.984 seconds, divided by 6.984. And we were at 2,300 rows a second. Now we're just north of 2,800 rows a second. So we're able to pick up a pretty significant boost there, maybe 500 rows a second in this, and where that's, 15 to 20% faster. So if this was running, taking, an hour to run, now it's probably running in the, in the 50-minute range. And that 10 minutes may really help your performance. And all we did was we just said the blob temp storage path no longer that temp directory on the C drive. We just moved it off the C drive. Move it anywhere off the C drive. But if you've got the opportunity, put it on a faster drive, and you're going to see, the performance improve just like we saw here. So you may be looking at this and going, Andy, that is just outstanding, except you're telling me that I got to open all of my packages, set that blob temp storage path, and then and then redeploy everything. Well, no, I'm not telling you that. In fact, I'm going to reset it and save it here. You can use this command line here. So I've got one in the I've got one here in the comment. I'm just going to copy this, and I'm going to zoom out so I can run start a command line here. Actually, I can do. That's something. Yeah, that's a Node.js. So I'm going to open this one. I know it's an admin. Oh, it's not an admin. Awesome. Better. And I'm just going to go to my E drive here and clear the screen and right click so that it pastes. And this is going to run that file, the same file we've got open as part of this property. We're going to use this set here. Now, if you're using SQL agent jobs to do this, and you've got a job step type, an integration services job step type, there's an opportunity, depending on whether you're running from the catalog or from the file system, you can adjust this. In fact, you can, if you're running from the file system, go in and edit the command line and put this in. And if you're using, say, the SSIS catalog to execute, you can still do this. It's on the advanced tab of the job step type, the integration services job step. It's called a property override. And this is the path that you would use. It's always /package/. then the name of the data flow task. Mine is named data flow task. Dot properties, always going to be dot properties bracket blob temp storage path. Case sensitive, so you have to make sure you get all that right. I put it in quotes, then a semicolon. You don't have to do the semicolon if you're doing this in the advanced tab. And then the property that you're going to go to. So I'm going to take this out. I'm just going to run this because it runs a little bit faster in here already, just so we can see how fast it actually runs. And we see it's kind of ticking through here. And the other thing that's happening is it does a truncate of the target table. 8.844 seconds total elapsed. Let's do that one more time. And again, that is truncating, and then it's doing the load here. And then I'll run it. So yeah, we're in the 8 plus seconds range. And if we do the blob temp thing here, we're going to see it run faster. I've not changed the package, by the way. I've just changed the parameterization of it. And now it's down to 5 seconds and some change. Pardon me. Try and edit that out. But you can see that it runs faster. So no, you do not have to redeploy your SSIS packages to the catalog or redeploy the files, even the DTSX files. You just have to know this trick that you can use a set switch here, and you can set blob temp storage path at runtime. So that's what I wanted to talk to you about regarding blobs. And let's see, our next demo is all about incremental loads. I love incremental loading. I think it's kind of the coolest thing ever. There's a number of patterns in this particular incremental loader package here. So one of them is I've got this dummy sequence container. There's nothing in here. And it's here so that I can have a start point for these two precedence constraints. And the reason is these two precedence constraints, you can see just reading the text here. And by the way, you get that to show up by changing the show annotation from the default as needed to constraint options, and it'll write down the words for you. It's a little misleading because it says completion and. Logically, that is correct. And the reason it's logically correct is if we open the editor, we're just doing expression only. I don't really care about what the value of the preceding executable is. It could succeed, fail, just as long as it completes. I'm golden with that. This is a package parameter called the whack and load bit. And what I find is over time, as I'm doing an incremental loader, and this path is most of the time what I'm doing. I'm just truncating a stage updates. That's another pattern where we stage the updates inside the data flow in a table, and then we come out of the data flow and we run this update with a join in it. This is pretty cool. It's a set-based update, and it flies. It's way faster than the OLADB command transformation inside of the data flow. Way faster. Even at this volume of data, like 20,000 rows or so. So that's yet another pattern. This is an incremental load, and I make it go faster by not putting in that OLADB command. And I go, again, one more thing that I do in addition to that is inside of the data flow, yet another pattern is I populate blob columns here, and you can see I'm on new rows. So when I select from the source, and I'm not including the blob columns in here. So I'm pulling everything else, but I'm going to do my change detection inside the lookup. I'm going to redirect rows that have no match to the no match output. Those are new rows, by the way. And we're going to consider that when we compare the source and the destination, that the source is more up to date than the destination. If there's a difference, the source is more up to date, and we want to transmit the source state over to the target or destination. That's just a thing. I call it ETL entropy because I'm borrowing heavily on physics, and the second law of thermodynamics gives us entropy and the arrow of time, and I consider that to be an arrow of time type. What we do in here is we just, again, select those same fields from the destination or target, and we're just mapping on the business key. So a business key, you can read more about that if you study star schemas. There's a great book called Star Schema, The Definitive Guide, I think, Chris Adams, good book. And I'm bringing back a bunch of these fields here from the destination. Now, they're named the same as the fields coming in from my source. They have the same data type. We hover over them. We see middle names, DTWSDR, length of 50. And over here, middle name, DTWSDR. So if we don't qualify them, if I don't give these fields coming back an alias that makes the name of the field differently, SSIS will do that, and it usually puts the source of the field or column dot then the name of the field for both of these, and that's just ugly. So I put DEST for destination. Sometimes I'll put lookup for LKUP for just any prefix will do. And so what this is doing is the lookup here is actually pulling the new rows out, and there they are, flowing right down the lookup no match output, and they go into another lookup. And in this other lookup, I fail the component if I don't find a match. You'll see why in just a minute. I go back to the source table and I say, get me the business entity ID and the blobs. And then I join on the business entity ID coming from my source originally to the, this is another query against the source. And the sole purpose of this is to add these two blobs. I'm doing this a little bit later in here, but there's another reason too. I like being able to do this as close to the destination, and I'm just writing directly to my target table here with these new rows. One reason I'm doing this is because I don't want these blobs hanging out here for a really long time, but the bigger reason is I have filtered the number of rows being fed into this data flow. So I've got rows in one of three states. They're either new rows, they're in the source and not in the destination. They're changed rows. They're in both the source and the destination, but other things have changed. And then finally, unchanged rows. And it turns out that if I execute this, we're going to see that it's going to pull in 19,972 rows, and there are no changes. That's pretty awesome, because what I forgot to do, and let's do that now, is simulate my changes. There they are. And I do this by, again, I'm not going to mess with my source, but I'm going to delete rows from my destination. Those are going to look like new rows. They're in my source, but not in my destination. And I'm going to update rows in my destination. Those are going to look like rows that have changed in my source. So I'm playing with the arrow of time here. I have a time machine, and it's a couple of T-SQL statements. If I re-execute this, and I'm just going to hold Control-Shift and press F5, we'll see those numbers. By the way, those numbers, 1175 and 818. That's what we just saw when I deleted and updated rows. And the way you test an incremental loader is you re-execute it. So we should have exactly what we saw the first time. No changes, no new rows. And this is what we want. But here's my problem with this. Let me pop back over here and re-execute this. Here's my problem. I'm picking up 19,972 rows here. But if you do the math on this part, 818 plus 1175 is 1,993. And that means I'm picking up just under 18,000 rows here that I am then throwing away right here. You see that? 18,979, sorry, 18,797. Dyslexia is a horrible thing. Minus 818. Those rows are being read into the SSIS data flow, and then they're just being tossed. And that makes this about 10% efficient. Do the math on that. 1993 is about 10%. So not very efficient. What I'd rather do here, and Shift F5 will actually stop this thing. I'd rather only pick up the rows that are new and have changed. So if I go look at my incremental loader here, and by the way, I didn't finish talking to you about my whack and load bit here. What happens over time if you're doing any kind of change detection is you have the potential to have rows missed that should have been loaded or updated, or have extra rows put in, duplication. Not going to go into all of the ways that can happen. I think I've written all of them, though, while trying to deliver solutions to clients over the years. But I figured them out, and that's why I'm able to share this with you. So you end up with some number of rows that are in the data warehouse, and then some fraction of those are bad rows. It's bad data. So if you duplicate, of course, and you're doing count aggregations, then that'll throw that data off. And if you're missing changes, of course, that can throw off things like sums and the like. And it really shows up when you start using, when you start doing predictive analytics on data in your data warehouse. That aggregation is a multiplier. And it turns out that if you do the ratio of good data over bad data, that you can get a measurement of the quality of data in your data warehouse. And most of the time, the quality of the data is well north of 99% when the function of that data warehouse, or at least some of the functions, become useless. It just starts failing to deliver what it's built to do. So in order to manage that, you can truncate the target. Here's my truncate table person.person in my destination database. And if I do that, and then I go and start my incremental load process here, then all of the rows are new. And you can do that if you've got a lot of data in a table, millions, billions of rows. You can do that over a longer weekend or something like that. I mean, you're not doing anything on a holiday weekend anyway, right? Don't get me started. So that's the pattern that's happening right up here at the top. It will reset those rows because a truncate and load just loads all of the data right over to your target. So there's no chance that if everything shows up as a new row, I mean, it's flowing down this data flow and it's going right to the right out of the no match output, and every row then directly to no change detected or anything else happening. But let's take a look at how this works, because this actually achieves that only pick up the new and changed rows piece. And when I talk about this, I want you to be aware that the options here to consider, you can kind of do a little matrix, a 2x2 matrix, and you can think of, I own the source database, or I don't own the source database. Maybe it's a third-party database. There's an end-user license agreement that says, if you mess with this database, you break it, you buy it. That could be, or something meaner in there. I've seen database update engines that will actually check for things like an additional index and delete it. That happened. And okay, and that would be awesome if the database was tuned to start with, but I didn't. Did I say that out loud? So moving on from that, you may not, even if you just violate the EULA, that's bad enough. So maybe you don't own the database, and we're going to treat our source like that. We don't own this database. We're going to treat our target like we do own it. And really, there's ways to any of the four quadrants you find yourself in: own the source, own the target, don't own the source, don't own the target. If you find yourself in any of those combinations, then you can manage and use this pattern. The other thing I like about this pattern is I'm going to be using the hash bytes function, and there's some other solutions out there to achieve exactly what I'm trying to achieve here. Things like change data capture and the like. I'm pretty sure change data capture is only available in enterprise. I may be wrong about that, so if I am, forgive me, but I can use hash bytes on Express. Okay, you can't do CDC on Express. So what we're going to do, because we own the destination table, we're going to start by running this hash bytes algorithm, updating a field called hash value. It's binary 20, and the output of the hash bytes function is going to be driven by the algorithm that you choose. And you see here I'm choosing SHA-1. Hash bytes, the function, has two arguments. The first is the name of the algorithm, and the second is a string. And so if I want to look at the state of all of the columns in this table, I can't use this, by the way, against blobs. If I want to do blob hashing, you can do that, but the way I've done it in the past is I've used SQL CLR, store procedures written in C# that are able to produce a hash out of the contents of a binary large object. But here I'm hashing everything except the blob. And we see here I'm doing a convert to varchar the business entity ID. This is an int value. Person type, I think, is a bit, not positive. name style, one of those is the title, and if it can be, if it's a nullable column like middle name here, I'm coalescing that string. Last name suffix coalescing to an empty. Well, email promotion, the row grid, converting that to varchars, and then the modified date. And I've also put pipes between these because I want to make sure that I generate a different value than, if I run into a scenario where, say, fields are running together, and I say that every time, but let me do a demo for you here real quick. I'm going to use one of my favorite data engines, Notepad. I'm kidding. I'm the pitchfork. So what if somebody's taking my information, and my name is Andy Ray Leonard, and I give them that information, and they're typing really, really fast. And they do Andy R, and they hit the tab key. And for the middle name, they put AY, and then they get the last name right. So if I wanted to, do some concatenation here, like I've got, for calculating my hash, if I didn't have the pipes in there, this would look like, let's say somebody types it this way first, and if somebody types later, they come back and they type it the right way. Well, it would compare. We're going to see, the hash value is good. That's going to be calculated here. Would do a comparison between these two values, and without the pipes, it looks like it's comparing these two values here. And you can see those two values are identical. So the hash that it would generate, even though the source and the target have different values in it, when it generated source and target hashes, they would be identical. These were the only, if there were no other changes in here. Whereas if you put pipes in here, this is going to generate a different hash than that. That's a different string. So that's one reason that I do this. And why did I come up with this? Oh, Andy, you're super cool and smart. No, I learned this the hard way. Like I learned almost everything that I know. I did this and forgot the pipes, and I got burned. I missed changes. That's bad. That's a technical term in data engineering. Bad. So putting the pipes in here manages that, and it ensures that when I'm doing this, it's going to produce the results that I want to. The other thing is people look at the SHA-1 and they go, Andy, I can't even browse to a page protected by SHA-1. It's so hacked. Browsers throw up a warning. They won't even let me go look at it. And I feel you. I'm with you. I just want to let you know I'm not doing encryption. I'm doing cyclical redundancy checks. I want a state of that row. I'm not trying to encrypt it and later go back and decrypt. I just want to know what the row looks like so that I can do a comparison of these values. And then, and if they're equal, I can do stuff. If they're null, I can do other stuff. So what I'm going to do right here, I'm just going to pull this piece out and then click OK and OK again. And we'll go over to SSMS, and we're simulating changes here. Let's make a new query. And in our, I think I want to do this in, no, I do want to do it in the destination there. So this is my destination database. I'm first going to simulate my changes, right? That's what happens in my destination data, testDB. And then I'm going to run the update of the hashes. There's only 18,797 rows to update. And again, I own this table, so I'm able to add a column to it, binary 20 named hash value, and then I can do that. But when it comes time to do the actual change detection piece, after that, I'm actually going to do that in T-SQL. And I'm going to do it in this query here. So I'm going to select all of that and show you how this works. So for this one, I do need the AdventureWorks use Adventure 16, I believe, is what I'm using. And here's how this works. Now, this is for demonstration purposes only. If you're looking at any of this code and going, I wouldn't do it that way in production, well, cool, me either. But this will show you the principles here that are involved, and this is the best way I can think of to do. I'm going to select all of these fields from the source, person.person table. You can see down here from person.person, which is aliased with a P. And there's my hash byte SHA-1. And here's the string, the big long string that I'm concatenating, and I'm naming it hash value. Now, I don't have to do this. I'm just doing it to show you again, show you what's at. Where I really need this is a little bit later, but we'll get there. So to pick up the new rows only, I don't need magic. I just need a left outer join. So if I join these two together on business entity ID equals business entity ID, my destination and my source business entity IDs. If I do that join and my destination business entity ID is null, guess what? That row exists in my source data, but not in my target. So all I need to do is a left outer join and say where the target business key is null. If I do that, I will get the new rows. And in fact, we can run this query from here up, and we can look at the results, and we can see there's a familiar number, 1175. We've been seeing that every time we delete rows. And we see 818 that are our changed rows. So if we scroll down, though, a little bit, and we look at this OR clause here, this is going to detect our changed rows. This is new rows up here. And our OR piece here is actually going to recalculate that hash. This is where I need to calculate it from my source. And again, why am I calculating this on the fly from my source? I don't own that database. So I have to calculate it there. If I don't own the source or the destination, guess what? I'm running two on-the-fly calculations here, and hash bytes is incredibly fast, especially if I use a SHA-1, which is a fairly small footprint here. MD5 is even smaller. But if I do this, and I compare these values, I'm joined. So this is where the business key exists in the source and the destination. Are the rest of the columns equal? And this is how I tell that they are or they're not. And I'm looking for the ones that are not equal. Why? Because that means that row has changed since the last time it was loaded. So if I do this and run the entire query, I get my 1,993 rows. These are only the new and the changed rows. And we go back to the demo and we execute this. And again, I'm picking up blobs later. So if I execute this query, we see that it only picks up the 1,993 rows. This is the big change. And actually, if you run this on this volume of data, you'll see it perform about the same. It actually may perform a little worse. It's not built for this volume of data. It's really built for, millions or billions of rows in the target here. And I re-executed it because that's how you test an incremental loader. Re-execute it, and you should see no rows. Look, this doesn't even pick up any rows. Okay? It doesn't read any rows because it doesn't have any rows to read. So if you've got relatively large amount of data that you want to do incremental loads on, and I would say 20-25% or less of the rows are changes or new rows every time you do the load. This is a really solid pattern for you. It's only going to pick up into RAM the new and changed rows. I hope that makes sense. Love that pattern. It has a lot of cool uses. So finally, what I'd like to talk about, my last chunk here, is I want to talk about using replacing functionality in a data flow with a script component. And as of 2020, it's 2020. As of 2020, this is a contrived example. This problem that existed 10, 12 years ago when I first built this pattern no longer exists. The ODBC driver that I'm using to talk to MySQL, and that's what I'm doing. I'm talking to MySQL actually in Azure. That driver has been fixed. It can now do bulk inserts. It flies. This is the old driver. And I'm not doing this to beat up on MySQL or any of that, or the ODBC destination or what have you. I'm doing this to show you that a script component in a data flow can make amazing differences in performance. And there are other examples that I could show you, but this one is the simplest and it makes the most sense. So what I've got is I have the out in Azure, I have a MySQL database. It's called MySQL Andy. And when I execute this query, what I'm doing is I'm looking for the number of rows in a table called sales. It's actually generated from Contoso. There's about 3 million rows in there. So I'm counting the number of rows that I've loaded, and I'm putting it into a field named rows count. That's over here. And then I'm putting the date timestamp right here. And I'm doing that so that I can show you some results in the another of the world's greatest data engines, Excel. So I'm just picking a little, but not much. So if we look at Excel and we see, you know, what the date, time, and the rows count, I've got a calculation here. The delta seconds, that won't show up until the second row. Same with delta row count, and then a little throughput calculation, rows per second. I do that because what we're going to see as we load this file is that it's going to pop right up here, and it's going to give us a good number. Love that number, 8,090 rows. When I saw that number the first time, I was like, cool, that's a fair buffer size. But I sat here and watched that number not change for a long time. And so I was like, something else is going on. And I started running this query. So we're going to copy this and zoom out and pop over to Excel and paste it. There's that first reading. Let's do this again. Run again. Grab the data. Pop back into Excel and paste the second row. And now we start to see what's going on, right? That is 9.15 rows per second. Not making that up. That's what the math says. And math doesn't lie. There's an old cartoon, Foghorn Leghorn, in the U.S. here. Maybe y'all had Looney Tunes where you lived as well. And Foghorn Leghorn once said to the little the chick he was watching after, he said, "I know figures don't lie. I know, boy." So that's my Foghorn Leghorn impersonation. That's no extra charge for that. And we're just going to keep picking through here and looking at these values. We're going to stop it after this one, but you can see it's not looking good. 8 rows a second. That's bad. That technical term again. So I'm going to stop this because it's still stuck on 8,090 rows. It's really not doing anything for me. And pop back into MySQL Workbench and truncate that table and check again. And we're back at 0. Okay. Copacetic. We're done with that one. What I was able to do, though, was through a little bit of clever coding. And I don't remember where I found this. I didn't write this, not all of this from scratch. I adopted a couple of chunks that I found out there. But I start with an insert statement here. And this is the way insert statements look into MySQL. They have these different kind of apostrophes. And I begin with that. I'm reading from the same flat file. I'm just writing to a destination script component here. And when you pop them in, it'll prompt you. Do you want to make this a source, a destination, or a transformation? Most of the time, you're doing a transformation. This time, I was actually doing a destination. You can see right here on script, I've got that read-only variable. I got my sales insert statement, the insert into part of a SQL statement there. Also, on connection managers, I'm reading from my a connection manager named MySQLAndy.odbc64. It's configured the same as the other connection manager that we had on the other side. And if you've ever done this with ODBC in SSIS, the Visual Studio component of this is 32-bit. So you need to make a 32-bit DSN and then a 64-bit DSN if you're going to execute in 64-bit. So that's what I did. But I'm telling you right now, the only thing I did with this connection manager is I used this to get the connection string from, because I have a username password, and I just want to read the connection string out of that guy, and that's it. I'm not connecting through that after that part in the script. And if we go look at the script that we're going to be using here, and I'm kind of zoom out here, and this takes about 30 seconds to spin up because it's reading from a C data block in the XML, and it's constructing the classes and everything that it needs here in Visual Studio Visual Studio Tools for Applications, VSTA. So here's how this works. I begin by declaring some variables and initializing them. There's a string called S1. I know I was feeling really creative when I built that. And then a string builder, S2. String builders allow us to append without destroying the original variable value, so it's not writing over it, destroy, recreate. This is fast. There's an end of row set that I set, and a command text, again, initialized as blank. I also create an ODBC connection, system.data.odbc.odbc connection. I name it myCN, my connection. In the pre-execute, I run the base class. This is an override, so I call the base pre-execute. And here is where I go get that connection string from MySQL. And that's it. That's the only time I use that MySQL Andy connection manager. But it's a great use of it because it's really tricky if you want to interact between script and connection managers. You need to know how to go get, especially if there's a potential for a username password login versus, say, like an Active Directory login. This is one way to do that. Another way, just so you know, is if you call on a connection manager, if you call the acquire connection method, you need to pass either null or some transaction that you've got configured. I've only ever passed it a null. If you call that, you can coerce that into a SQL connection. And when you do that, when you put the SQL connection parentheses ahead of that, it returns to you a SQL connection, and it will be connected to that data resource that's using a SQL login or just a login. So just an interesting way of doing that. I don't know any other way to get the password out of one of those from script other than calling that acquire connection. So once you do this, I've built a new ODBC connection. There's my connection string. I assign S1 to variables.salesInsert. Could I have done that in a pre-execute? Yes. And then I opened the connection, the ODBC connection. In post-execute, so after we've done with everything I'm going to do in the middle here, I call base post-execute. I've got this function or method here called write buffer, and then I close the connection. So I'm going to do more write buffers here in just a minute. In fact, you see when I process the input here, and this happens for every buffer of data that flows through here, I call write buffer. Why do I call it here? Because there's a piece of a buffer left. Okay, so in post-execute, I just go ahead and write that piece of a buffer. And we'll see the write buffer function. It doesn't load anything if there's nothing to load. So if I happen to get the exact right amount of data, it just doesn't do anything. Call it here at the post-execute. Here's what I'm doing per row that's flowing through. I'm initializing the string builder if it's not already initialized. And then I define my variables here. So I set up sales ID, and I manage nulls in here so that, my values are in this case, I'm putting a 0 for a null. I'm setting up the date key field here. And I just go right through date strings and blah, blah, blah. All of the things that are in that sales table. And this was generated from Contoso. Here's where I built what I labeled a poor man's bulk insert. So here I append to the S2, the string builder, select, and then all of these values. I convert stuff to, strings that need to be converted. And I put tick marks where I need to have tick marks. And I just build this select statement. It doesn't have a from clause. I don't need a from clause because I'm just union and all, and it's just selecting values at this point. Select the values, union all, select the other values. And in the default max buffer rows, I forget the exact name of that, but the maximum buffer row setting for the data flow, I set that down to 1,000. What I end up with is roughly, it's not exactly, but it's close to 1,000 of these select statements that are union alt. I told you, it's Andy's poor man's bulk insert. If an exception happens, throw an error, of course. And then in my write buffer, here's where I put all that together in my command text. And I say S1, that's my insert into, plus S2, that's my big list of selects with union alls. and I build that together, and then I knock off the last union all. That's what the length minus 10 is doing for me. I don't need that. That would blow up. And then I say if s2.length, if I happen to nail it and it's right on the border, the right number of rows, and it's an empty S2 because I've hit the last buffer and I'm coming through here and post execute. If it's greater than 0, then I execute. But if not, just stop here. You're done. You loaded it already. I declare a new command, ODBC command, using my command text and myCN, that connection manager. And then I execute non-query. This is all .NET, typical .NET. Then clear the string builder. And that's it. And the net result of this, when we run it, is that it runs a little faster than what we saw. Now, again, I'll remind you that this is contrived in a really, really old thing. But it wasn't, I want to say it was like 6-7 years ago when they started fixing this. They first made the ODBC go faster, and then they did some other stuff. I think they added bulk inserts. So if we copy these two values, go back to Excel, and let's delete here. We got all the way up to 583 rows, right, last time. So we paste this. We're a little beyond that already. Run our query again, and back into Excel. Oops, I got to copy this. Back into Excel. Paste this, and now we're at 840 rows a second. Not too bad. Run again, see what we get. But the fact that you can see the buffer changing, right? And this earlier today when I was running this, I was getting over 1,000, 1,100 rows per second. This is still knocking on, 100 times that performance. And the only thing that I did was I converted this using .NET inside of a script component. I think I'm out of time just about, but I want to share with you one resource for this. People ask me about how much C# do I need to know to do SSIS. And although it's unrelated to the presentation that we just did, I go to bimlscript.com's free website, and on there's this C# primer. Scott Curry wrote this. Scott worked on the C++ compilers for Visual Studio at Microsoft for a few years. If you're going to learn .NET, you might as well learn it from Scott Curry. And this takes you maybe an hour or two to walk through. And this is enough C# to get you a solid start in SSIS and also in Biml if you want to learn more about Biml. But it's just a pure C# primer here, and it's fantastic. It's just fantastic. So that's it. That's my talk. I'm going to stop this loader here because it'll load all of those rows. It's chugging along there. If you saw, it was up over 100,000 rows there doing that. And I'd really like to just let you know, if you want to learn more about me, another place you can go is andyleonard.blog/learn-more. And if I can help you with anything, please contact me, andy.leonard@entdna.com. And I would like to conclude by saying thank you. And it is always an honor.